All right, Chapter 8, Section 1, we'll talk about multiplying and dividing rational expressions. Rational expressions mean fractions for the most part, except now instead of just all numbers, you're going to see variables involved. Now, you have all done something like this in the past. And typically, somebody will say, well, I'm going to reduce this, I'm going to reduce this. I'm going to show you the long version. I get it. A lot of you can probably do that in your head. Somebody will say, well, I'm going to throw it in the calculator and do it. Awesome. Problem with variables is you can't throw it in a calculator to do it. So let's break this down. What's back in the good old days of prime factorization? 2 times 2 times 5. 5 times 7. We're still multiplying the fractions together here. So 21. 3 times 7. And then the 48. 2 times 2 times 2 times 2 times 3. Now, reduce the fractions. Vertically and diagonally, cross reduce. So a bunch of different options you can have here, but I can see the 5s cancel out. Again, many of you saw that ahead of time. I can see the 7s cancel out, and when there's nothing left, it's a 1. I can see this 3 and this 3 cancel out, left with a 1. Factor of 2, a factor of 2. Another factor of 2, leaving us with 1, and another factor of 2. Final answer, 1/4. Now, some of you are going to say, gee, that seems like a long way to do it. I agree, it is. But this is the breakdown that we're going to have to do when we start getting variable expressions or algebraic expressions in here. So what's this going to boil down to? We must remember our factoring patterns. And remember, we're working with fractions, so fraction rules. So another example, again, going back to just the good old days of fractions. We had 40 divided by, or over 63, divided by 16/27. We all know the golden rule of keep, change, flip. Or multiply by the reciprocal. So we keep 40 over 63 times 27 over 16. And again, I'm going to break it down completely to give you the idea of what needs to be done. 2 times 2 times 2 times 5. 3 times 3 times 7, prime factorization of both those numbers. It's now become a multiplication problem because we keep, change, flip. 3 times 3 times 3, and again 4 to the 4th power. So we look to start canceling. Here, 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 here. I went diagonally on that. Nothing here, but we can go diagonally here. 1, 2 factors, 3 factors of all that. 5 times 3, 15. 7 times 2, 14. And again, improper fractions are fine. Keep it, done, move on. Okay, so now how are we going to apply this to algebraic? Well, your instructions on a lot of these, at least in the beginning, is going to be to simplify. So we look. Let's say we have 5x times the quantity of x plus 2. And then we have 3 times the quantity of negative 4 minus 2x. Okay, so looking at this situation, remember you can only, going back to what we had up here, you can only reduce when it's a multiplication operation, whether it be diagonally or whether it be vertically. So before we start saying these twos and stuff, these signs are important. Multiplication, multiplication. So the 5's eligible. The x is eligible to be canceled. This whole quantity is eligible to be canceled, but I don't see it. This 3 is eligible. So right now, first person looks and says, oh, I can't do it. Remember, look to factor. We want common factors. We're looking for, if you will, GCFs to get out. So if I see an x plus 2 here, I notice there's a factor of 2 here, but there's both opposite signs. So factor out the negative. I can get a negative 2 out of this and a negative 2 out of this. So as we factor it out, we'll see 5 times x times the quantity of x plus 2. Here's a multiplier of 3. So 3 times, if we factor out a negative in this case, we're left with positive, now negative 2 is what we factor out, left with a positive 2 here, and we're left with a positive x here. What property allows me to switch the order? So I look and I see that this is common to this. This whole quantity is a factor. This whole quantity is a factor. So there's 1, 2, 3 factors up here now. 1, 2, 3 factors here. These two are common to each other. So they can cancel each other out. Nothing common here. So we're left with 5x over negative 6. But as we know, this negative applies to the top or to the middle of the fraction. So we go to this point right here. Now, new that you didn't have to do up here is you have to check for stipulations. And we talked about this, it seems like a while ago. We're talking fractions here. Fractions can never denominator can't be 0. So when we check for stipulations, we check the original. Denominators, plural. Check them all. Sometimes some people do this in the beginning. That's your call. So there's our original denominator. There's no way that 3 is going to be a 0. But this in here has a potential for 0. If somebody plugs something in here, it gives us a 0. So how do we do this? Some of you can see it in your head already. Others, negative 4 minus 2x equals 0. All right, add 4 to both sides. Negative 2x equals 4. X equals negative 2. If somebody plugs a negative 2 in here, you get 0 in your denominator. Up here, doesn't matter. Here, somebody plugs it there, you get 0 in your denominator. We can't have it. So we have to put our stipulations. X cannot be -2. Fractions, we have to be dealing with that again. Okay, let's continue here with another example in terms of just reducing fractions or simplifying. Let's say we had 12 c to the third d squared over 21ab times 14a squared b over 8c squared d. Now, we're talking about stipulations. A lot of times in instruction they'll say no denominators can equal to 0. Again, we all know that none of these can be 0. So if you really wanted to, A, B, C, D cannot equal 0. If you wanted to, put that in there and be a stickler about it, but you don't have to. So we look. It's a multiplication problem, so I don't have to worry about flipping anything. If you want to write out all your factors like I broke down before, you can. Don't have to. We start looking at things. I see an A here. I see nothing up here, but I see one factor of it here. So I can cancel out to a 1. I see a B here. Cancel. Cancel. I look, again, you can look a bunch of different directions. Here's a 21. Here's a 14. 7 goes into 21. 3 times it goes into 14. Twice. Somebody's going to look in vertical. 3 goes into 12. So all of this has been canceled out. We got a 1. Left with a 4 there. Somebody's going to look here. Somebody's going to look here. Again, personal preference. I see 4 goes into itself. 4 goes into this twice. Somebody else is going to say, oh, look, I noticed those cancel out. So we're left with a to the first, so far up here, c cubed, d squared, 1, c squared d. So I got some more canceling I can do. This factor of d, this cancels to a power of 1. C squared will cancel 2 of those out of there. So everything is canceled into 1 here. Everything was, again, canceled to 1 here. Those 2 factors knock off 2 of those. Left with c to the first. So, what are we left with? 1 times c times d times all that stuff, a. So we're left with c, d times a. Some of you will put that in alphabetical order. What's on our denominator? 1. And again, if you really wanted to, a lot of times the directions will take that away. Let's see here. Got that. All right, let's look at something like this now. And again, factoring. So I'll give you this. 2z times the quantity of x plus 5 times the quantity of z squared plus 2z minus 8 all over quantity of z minus 1 times the quantity of z plus 5 plus sign, and then times the quantity of z minus 2. So I'm going to go back and change one thing. All z's, and all of a sudden there's an x here. Should be a z. Just habit. My bad. Sorry. So, again, seeing big things like this, the directions are simplify. First thing somebody's going to do, in this case, I'm going to say let's find our stipulations. So our stipulations, look here. If we plug a 1 in there, we get a 0. Multiply it all through, it's still 0. So z can't equal 1. Stipulation here, that's a plus sign. Can't be a -5. Can't be a 2. If you want to get those out of the way right off the bat, good. More power to you. Have at it. Now, factoring patterns, factoring patterns, factoring patterns. Look to factor. So we see, can't factor that, but this has a potential. Two factors of -8 that add up to be a +2. Well, let's see. How about +4, -2? Product, yes. Sum, yes. So, as we break this down, 2z times the quantity of z plus 5. Break this down times the quantity of z plus 4 times the quantity of z minus 2. Nothing to break down here. Z minus 1, z plus 5, and z minus 2. Now quantities are considered factors, so we are going to reduce them out. Cancel, 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 cancel. They all had the same signs. We're good to go. So as the dust settles, what's left? 2z times the quantity of z plus 4 over z minus 1. Z's can't cancel. If you want to do this, do so to remind yourself. One final note on this part is, don't expand it. So these stipulations go with that problem.